Good morning. My name's Grant Mitchell, as Riz said, from Sustainable Vehicle Solutions. We're a privately owned business based here in Hallam in Victoria. We also have an operation in Regency Park in South Australia. We're part of the CMV Group, which is a 90-year-old family-owned company, operated by the fourth generation. We represent all the famous, well-known truck brands in Australia. About 12 months ago, we set up Sustainable Vehicles to take on the Foton electric truck range in Victoria and South Australia. So just quickly, on Bake Foton, that's the company out of China. They're the largest truck manufacturer globally. They manufacture utes, commercial vehicles, and mainly trucks of all sizes. They're also the largest EV truck manufacturer globally. Last year, to put some scope around it, the Australian market combined with our efforts was around 200 electric trucks, and we're talking around that 4.5 tonne upwards. In the US, all brands were about 2,000 trucks. In Europe, all those well-known brands of Mercedes and Volvo, etc., was about 5,000. Foton did just on 50,000 electric trucks globally. The Chinese market was approaching 200,000. All things EV, the Chinese are so far in front, it's not funny. You can see there, they're sold in 110 countries. They've got R&D facilities globally. They're selling now in Europe. There's a thing here called the WVTA, the EU. That's a whole vehicle type approval. So if you want to sell an electric motorbike or a truck or a car, you have to get that approval. It's about 800 different test points. Think of it of ADR on steroids. And unless you've got that, you can't sell or import a vehicle in there. Foton was the first and right now the only Chinese electric truck manufacturer that has that. An interesting thing about Bake Foton, which just to put some scope around it being a Chinese company, is that they're actually Mercedes-Benz largest shareholder globally and Daimler Truck's second largest shareholder globally. That's how big this organisation is, and it's pretty good to be part of this company because they're just so far advanced. We have a number of trucks, and as Riz said, we've got a tipper out there which we've developed purely for the councils here in Australia. The actual body's built by City Coast up in New South Wales. They worked with us. It's the only electric tip truck available in Australia at present. We've got it working in parks and gardens type applications where you can see up to 30 to 120 kilometres a day. We've had it out on demonstration with a number of well-known councils, and basically we're able to map it with our telematics. We use Geotab, and the average kilometres a day are around 30 to 40 kilometres. Many of you would know you're going from one park to another, back to depot, etc. We have the vehicles working on furniture delivery. Here in Melbourne, I think there's now about 25 trucks working on the IKEA contract. So if you're getting IKEA furniture to deliver to your house, more than likely it's coming on the back of an electric truck today. I think nationally there's about 40 odd running around for the IKEA contract through various transport companies. Also in wine delivery, NTS Transport down on the Mornington Peninsula, they're picking up pallets and cases of wines and taking them to their warehouse from the wineries. Then they're going to deliver them to restaurants and cafes and whoever drinks, basically. And on food delivery, that last picture is a refrigerator truck, all electric with a Mitsubishi refrigeration system. A well-known supermarket chain has a large fleet of these. They've got the largest EV truck fleet in Australia by a long way. They'll probably have about 200 trucks running around by the end of this year alone from that point of view. They actually operate 2 shifts a day. They're doing an opportunity charge during the shift change and also overnight. They've got a combination of AC and DC charging. One thing I'll just point out, anything you know about EV passenger cars, forget about trucks. Most of it doesn't translate, apart from the actual design principles around using electricity, electric motor, and a battery source for energy. So this is the tipper truck here. We talk in truck world, and again, as I just said on the passenger cars, it's completely different. We go from 100% state of charge, that's what SOC stands for, abbreviated, down to around 20%. That's the usable energy that we like to talk about. Once an EV truck gets down to 10%, they go into a conservative power mode to protect the actual battery pack and system. That will basically put you into about a 60 kilometre, 65 kilometre speed limit. From that point of view, you don't want to go under that if you can, because if it gets to zero, you have to call a tow truck from that point of view. So going down to 15% is fine, 13%, but don't get to 10. Most of our customers sort of manage their fleet around that. So when you hear someone's got, if we use as a round number, 100 kilowatt battery pack, you don't get to use 100 kilowatts. You get to use around sort of 70 or 80%. And I'll talk about something in a moment. This particular unit's got a 6-tonne GVM. The whole truck, you can see there's got a tear of 3.6, so you're talking about 2.4 tonne payload. It's the only electric truck on the market that's actually got a GCM rating, which is a gross combined mass, which means you can tow a trailer from that point of view up to 3.5 tonne braked. Oh, sorry, I'll just go back. That's Jason from Lodex. That's actually over in South Australia. They purchased that truck to rent out to councils over there, because councils are trying to, make that big decision and don't want to put, make the big investment up front. So they go and rent that truck off Jason for a week or a month or something like that. They've had that now for about 4 months, I suppose, 5 months, and it's going really well. That's just an overview of the truck without the cab and all the things involved. The battery packs aren't painted blue, but we've just got it for the graphics there. But that's where it's running the two battery packs of 81 kilowatts. So you've got about 40.5 kilowatts between the two. And you can see the main drive motors actually inside the chassis rails. Next generations are going to e-axles and that, but they're still a few years away. So some of the questions we get asked on a daily basis is what is the range, and also how long does it take to charge? I tell people it takes 90 seconds to charge your truck, because you go and plug it in, then you walk off. That's as simple as that. Whether you're going to need it for 3 hours or overnight, it doesn't matter from that point of view. But I just want to touch on a few important things. Battery EV range is impacted by those key points there: road speed, driver behaviour, etc. Road speed is the biggest killer. The faster you go, the more energy you're using. Trucks love driving around urban environments, stop-start. You'll get a far greater range. Our truck has up to about a 200 kilometre range, but there's so many factors. We have 2 models available today: 4.5 tonne, which is available to driven on a car licence, or 6 tonne GVM, which obviously you need a light truck licence. So just depending on your application. The tipper application, we tend to go to the 6 tonne, because at 4.5 tonne you won't have much payload from that point of view. And I spoke about the usable energy. We tend to run down there. I think it was Brett touched on the battery chemistry. Lithium batteries, or lithium-ion batteries, is just an umbrella term. There's a number of chemistries in there. The 2 main chemistries, and the main chemistry that was around for many years, is NMC, which is nickel, magnesium, cobalt. That's got all that precious metals that come out of Africa, questionable mining practices. They're very expensive, and they've got a lot of inherent issues with them. And then you have LFP, which is lithium iron phosphate. It is the more dominant chemistry today, and has become over the last few years. As you can see there, LFP has a longer life cycle. They will last 5 to 8 to 10,000 life cycles. There's actually studies coming out of different institute research facilities around the world where NMC, I think maybe, no, sorry, I'll go back, I don't have that picture there, where NMC has life cycles of 1,500 to 2,500. In your passenger cars, it's probably not a major issue. But in trucks where you are actually charging every day, twice a day, it becomes an issue. So with an NMC battery pack, you're probably going to get maybe 3, 4, 5 years out of that battery pack, and then you're going to have to replace them. It's going to impact on your resale value. With LFP, you don't have that issue. They're going to last 15 years. We put an 8-year warranty on our batteries. We're quite fortunate. Some of you may have heard of CATL, or known as CATL. They're the largest EV manufacturer of batteries globally. They have about 40% market share globally. Our friends from Tesla about 18 months ago took on LFP. And because of that reason, China at the moment accounts for about 80% of all EV production, battery production globally. Of that, 75% now is LFP. So all your BYDs, that's all your Blade batteries, they're gone down that path. Tesla's switched a lot of their products over to it as well. NMC still has a place, not necessarily in trucks, and obviously still in some high-performance passenger vehicles. But again, the thermal stability of LFP, you can fire a bullet into it. There's actually YouTube videos. It won't explode. The vast majority of vehicles have caught on fire, whatever, has been NMC. I actually don't know of any recorded publicly LFP fires. There's been a few buses we've heard about in China, but that's about it. So when you're considering a vehicle, doesn't matter what it is, I'd be asking, what is my battery chemistry? The other issue with NMC is that you can only charge to about 80% to 90% regularly. Otherwise, you get degradation very quickly. And I do have a chart, but I don't think it's on this presentation. But it just drops off so quickly from day one, where LFP lasts so much longer. There's an Sandia Institute out of the USA. They do all the federal and Department of Defense USA government research facility, and they actually have a lot of data on the difference of the battery chemistries and how the degradation comes into play. The other thing I want to touch on, that middle slide there, you can see there is slow charge, fast charge, ultra fast charge. And you hear about people, we can charge in 30 minutes an hour. I'd forget all that. It's just really marketing guff. It doesn't mean anything because batteries don't charge in a linear rate. They go up in different cycles. They start off slow, go up, and then they taper off. And that's just a fact of life. It's chemistry. There's a whole lot of things going on depending on the ambient temperature, the temperature of the battery itself when you're going to plug it in, and then it goes and cycles through it. They have cooling packs. The cooling packs kick in when you're actually charging as well as when you're driving the vehicle. 1C is your typical centre point. So that means a charge rate, and this is for charging and discharging, and the vehicles are designed to actually control this sort of rate. So right now, all of our trucks are about 1.2C. From that point of view. Globally, out of all EV vehicle manufacturers, Tesla's got, I think, 2 or 3 models, and the guys might be able to confirm this, that have 3C capability. I think they're the high-performance models. There isn't a truck globally that has 3C or even 2C. And what that means is over 100 kilowatt battery, in theory, would take 1 hour to charge if you plugged a 100 kilowatt charger into it. If you plugged a 200 kilowatt charger into it at 1C, it won't charge any faster. You need a 2C capability battery cell. CATL just released late last year the Shenzhen cell, which is at 4C, and it's in a couple of passenger cars in China right now. It just doesn't exist. So if someone's telling you can charge that battery in 5-10 minutes, don't believe them. Do your research yourself. And as you can see here, we have the AC battery charge. We have an OBC on board, which is your onboard charger converter. It's got to convert the electricity from AC to DC because batteries only take DC, direct current, and ours has a maximum capacity of 11 kilowatts. Most passenger cars have 7 kilowatts. Our friends from Tesla, I don't work for Tesla, by the way. I just think they've led our EV revolution. So you've got to take your head off to the guys. And they have a 14 kilowatt. They're upping that. Some of the larger trucks we have coming are up around the 22 kilowatt for AC. You can't charge it any quicker. Simple as that. And you'll see there an 81 kilowatt, you want to put in 65 kilowatt of energy, it will take 6 to 8 hours depending on a whole lot of factors. You plug that into a DC charger and at 1C and you plug in a 40 kilowatt charger, as you can see there, it's going to take 1.5 to 2 hours, again, depending on where you are. You also hear about this 80% cutoff. That is just a furphy, okay? It's not that simple, it's not that predictable. If you plug in at 20 or 30%, it'll start tapering off maybe at 70 or 80% or 82%. You plug in at 65, 70%, it will keep charging at full whack, full amps, right up into the 90s. That's a fact. I've done a lot of testing on this. We have a lot of data out of China from that point of view, and globally, all the anecdotal evidence. Cost of ownership, I don't have the privilege of friends from the excavators where it's cheaper. We're twice the price. Some of our competitors are 3 times the price. Anything coming out of Europe is 3 to 4 times the price. The US, they're a bit behind. Most manufacturers out of China and us from Foton, we're about twice the price, maybe 90%. But from day one, your total cost of ownership can be equal to a diesel truck if you're doing over 40-odd thousand kilometres a year. If you're doing less, and a lot of councils will do less, you may pay a small premium of $200 to $300 on your lease payment, because that's how most people fund trucks. They don't just go throwing $200,000 or $300,000 of cash to purchase a truck. But you can see there the 2 columns here. That's basically on 1,000 kilometres a week, a 5-year finance term, and diesel at $2 a litre, and the electricity rate at 20 cents. I do a lot of these calculations for customers, and some people pay 6 cents a kilowatt hour, some pay 36 cents. Some have got solar on top of their buildings and are getting it cheaper again. So everyone's different. We have quite a complex TCO calculator. You can contact me and I'll do some scenarios for you from that end. The other thing that we've just recently dawned on, and this was last year, is productivity. And this was based on some observations where we had customers who send their trucks out for 6-7 hour delivery run with a diesel truck. Our electric truck was coming back an hour or so quicker. Simple as that. So we talk about up to about a 20% saving. I'm actually part of a research project with the University of Melbourne at the moment, which is almost like a world first sort of research project. I don't know if anyone knows of the University of Melbourne. They have what they call AIMS, and it's the only globally live urban transport monitoring system using the streets in Melbourne. And they're monitoring things from vehicles, trucks, push bikes, people walking. It's quite innovative. Go onto their website and you'll see what they're doing. And so the Professor Thompson, myself, and some PhD students have started a research project into efficiency, productivity, predictability of EV trucks in the marketplace. So it's an ongoing thing. But you talk about if you're saving 20% over a 7-hour shift per day, that's $23,000 a year in productivity savings. So if you've got 10 trucks, diesel trucks today, you might only need 8 electric trucks, our Foton brand or even one of our competitors. And the EV truck future, just touch on that, as I just spoke about the University of Melbourne. Cattle are working on more developed some LFP. These guys have about 7,500 active patents on EV batteries and cell-to-pack technology. And that's one of the advantages you get with LFP over NMC. You don't need the same amount of cooling because they don't get as hot in theory. They're not as, their thermal stability is a lot higher. But our trucks today are doing 200, they'll be at 350 in the next couple of years pretty quickly from that point of view. We actually have new trucks coming in the larger range. They're being sold today, not in 5 years' time. They are available today on a global scale. Mainly the Chinese, the Europeans have caught up pretty quickly. But with Foton, we just brought into the country an 8x4 concrete agitator, carrying 8.5 cubic metres of cement, concrete, sorry. It's going on trial for a few months, and we're doing the ADR, and that'll be hopefully, fingers crossed, available for sale later in this year, along with other sort of 10, 12, 14 pallet sized trucks, which you can put a larger tipper body on for councils, etc. They are coming. Your intrastate sort of work where you would need to do 300 or 400 kilometres a day, it's not far away. It's only 6, 12 months away. B-doubles in Australia is quite unique. It may need a different combination of battery swapping. In China today, they sell about 1,000 trucks a month of all brands that have battery swapping capability driving down the highway. So from Beijing down towards Hong Kong, they've got charging stations every 100 kilometres. Trucks, semi-trailers drive in, and in 5 minutes, they've driven out with a fresh battery pack. They've automated gantries, they go on to charge and just keeps going and going and going. Battery swapping may be the answer for Australia, like it is for China at the moment, until the technology gets up there. Cattle's released their another cell that's at 500 watts per kilo, which makes aviation possible. If that cell gets into transport vehicles like trucks and cars, which is probably 4 or 5 years away, it's the game changer. But I think they'll get there a lot quicker from that point of view. So I think that's about all I've got to say on that. So thanks for your time.